Okay, here is the answer. So is that right, class? Okay, so this we have the methods of finding partial derivatives as a given point. So we have just question number 1. Now we move on question number 2. Okay, given the questions, question number 2. Let's evaluate, okay, d square f over dy square as 2, 4. It means that we are having second order partial derivative.
U phẩy là bao nhiêu nhỉ? U phẩy là 6.
All right, in these questions, we are evaluating second order derivative, and you have to notice that we find second order derivative with respect to y, and in 2 times mean that you have to find the derivative 2 times twice, right? And in both times, y is variable and x is constant. So it means that we can fix, okay, we can fix x firstly, because both time, okay, because both times y, in both time y is constant, sorry, y is variable. In both time of differentiating, y is variable, right? It means that we have x, we fix x as 2 here, and we keep y, so it's become a function gy, and is equal to, we have here 8, right? 8 and 5, 40 y, and here we have cosine 6y minus 2. And then we have that second order derivative of this function at this point would be equal to second order derivative of gy when y equal to 4. Okay, and you can check this. First of all, you will need to find first order derivative first. We have, okay, cosine 6y minus 2, right? And minus y 6y, right? Sine, here we have 6y minus 2. And we take the derivative of this as y equal to 4. Next step, in the last step, you can use your calculator to compute. Your calculator have the function of finding the derivative. And here is, we have the results of this one. So everyone can find this answer, class. Is there any questions? Okay. The next questions. Now we take another questions. It's also one topics. Okay. Let's consider the next question. And this question is about chain rule. Okay. It is about chain rule. Okay, we have one question on chain rule. Okay. Well, I give you some minutes to answer these questions, and then you give me, I call your names, okay, to give me your questions. Okay, viết ký, Nguyễn viết ký. So, do you hear me? Nguyễn viết ký.
Hello.
Okay, let me know your answer.
Yeah, I'm still calculating, teacher.
Okay, I will wait 1 minute more.
Oh shit. Trời, cái mình nó u trời, cái quái gì đây? U11. Teacher. Yeah, I'm still finding it.
So, have you got the answer?
Yeah, I have just typed on the chat sheet.
Mhm.
Can you
I,
have a look?
I see it. Okay,
Chat sheet.
let's check. Yes, okay. That exactly have 67 point. Okay, so the answer is 67 38, right? So we can apply the chain rule here. With this question, we can apply the chain rule with the pair when UV, right, equal to 1 and minus 1. Then we have respectively, we have correspondingly that X, Y, and Z. You can see that here we have this 0.8, right? Okay, this is we have what? U. Okay, we have 1 and plus 0.2, so we have 1.4. Is that right? And also we have Z equal to 1. All right, and you can see that this function, okay, this function depends on XYZ, but here is depend on XYZ, and XYZ depends on UV. Okay, why depend? So you can apply the chain rule for this one. Then the derivative of G with respect to V would be equal to, we have G with respect to X, that is variable in the intermediate level multiply with xv, right? And plus we have gy multiply yv and plus bc multiply cv. Is that right? And gx here, gx we compute gx at this point, all right? So it means that we have gx. What is gx? The function gx, let me call this point is m. Okay, let's call this point is m. So you need to find gx we have expression gx 6x, right? Okay, minus 6yz and replace m here, multiply xv and multiply with minus 0.7 and plus gy. What is gy? We have gy minus a z square, right? And minus 6 x z at the point m. Multiply with yv. We multiply with minus 0.4. Okay, and finally we have derivative of z with respect to z. This is we have plus minus 16 yz, right? And minus 6 xy. We replace m here and multiply with derivative of z with respect to v. We have 2uv, and in this function 2uv we replace u by 1 and v equal to minus 1. And the answer is 67.38. Okay, another question. Question number 4. Let me know what is the answer for this one. Let C be a function of x and y defined implicitly from the equation. Okay, here's question number 4. Given that z when x equal to 1, y equal 0 equal to 1, evaluate zx at this point. Okay. Nguyễn Khánh Duy. Nguyễn Khánh Duy, are you there?
You there?
Teacher.
Okay, so let's show these questions. Let me know what answer you get.
Is Z nè, nhân cho Z nè, bằng 3. Mấy ông lồn là sầm lồn chết điểm mẹ tụi mình.
So have you got the answer?
Not yet.
Duy?
Not yet. Please.
Right, it took you so long. We have only about 2 minutes to do this time exercise.
Cái lồng má khó vậy lồng.
Is there one hard answer? I don't think this is difficult questions. Okay, it should be 0.3. Why do you get minus? Okay, so in this case, we rewrite, let's rewrite the expressions. Okay, let's rewrite the expression f. This is equal to the equation we are given is minus 3x plus 10z, right? Okay, and now we need to find all three. We need to find three partial derivative at the point. Okay, we need to find fx, fy, and fz as the point x equal to 1, y equal to 0, and z equal to 1, because we are given that the value of z at this point equal to 1. Okay, so well, to find fx at this point, okay, as 1, 0, 1, I fix y and z. So if I fix y and z, it means that I remain. So if we replace y at 0 here, okay, so we get the first term becomes 0, right? It becomes 7 cosine, right? We have y plus z equal 2, so we have here cosine 1 minus 3x and plus 10. And after fixing, we take the derivative of this function as is equal to minus 3. About fy as 101, okay? Fy at 10, so we fix x and z, and if we fix x and z, so we have e, right? Minus 7. This is we have cosine. Well, if we replace, we keep y here and we replace z by 1, so we remain only cosine y. right? This is we have minus 3 and plus 10. This is becomes 7. Okay, and we find the derivative of this function. The derivative of this function equal to 6e, right? Plus 7 sine y. And we replace y at 0 here. We remain 6e. But at z, at this point, okay, at z, we find the derivative with respect to z. And also we can fix y and x, so it becomes 0 here. It is minus 7 cosine. We keep z on only, so it become, here we have, if we take y at 0, right? If we fix here y at 0, so we get cosine z minus 1. Is that right? Okay. Minus 3 and plus 10z. We find the derivative of this function, and then we get 7 sine z minus 1, that's it, and plus 10. Then we replace z equal to 1 and we get 10, right? And so then we, okay, because we find zx, right? Sorry, we are finding zx, so it's not necessary to find z fy. It's not necessary. But here, from here, we can give the answer for both. We have zx, okay, equal to minus of fx, so minus of minus, we get minus 3 over 10, right? And zy, we have minus 6e over 10. Remember that's in the formula we have minus, so we have here 0.3. Okay, now let's take the next questions. Okay, we take question number 5. Among all unit direction, there is a unit direction so that the function f decreases more rapidly at m in this direction classified. So we have another questions. Question number 6. Okay, take question number 6. So what is your answer for question number 5? Nguyễn Hiền Đạt. Nguyễn Hiến Đạt.
Can you hear me?
Okay, so as I explained in theory, right, we know that a train passes in the direction of vector gradient. So now the question is F should decrease more rapidly. Here F trains by, we know that the direction of increasing fastest. Okay, so this is the topics on directional derivative, and so we have to take a look at directional derivative. Okay, as we have some statement that f increase, okay, or decrease fastest, okay, in the direction of vector gradient f and minus gradient f. So in this question, vector function f must decrease most rapidly, and the direction that f decrease most rapidly is minus gradient. And so first of all, you have to find the vector minus gradient of f at this point. So first we need to compute. We have to write that f decrease, okay, most rapidly, okay, rapidly in the direction of minus gradient f of m. So you need to find vector minus gradient f of m. But here we are required to find unit vector. So the next step, you have to find the unit vector, okay, the unit vector in this direction is. So because you already has vector, you can find a unit vector in that direction, right, by dividing the vector with its length. So you know how to show now that.
Yeah, as calculating the result.
Let's calculate it and give me your answer. What is the answer for this? What is U1 and what is U2? Okay, can you give me the answer in decimal number? Let's round the answer to 4 decimal place. No, I don't think your answer correct that. Let's compute again. So the unit vector is you take the vector minus gradient f at m, okay, divided by its length. Okay, so then we have the answer is what is U1? That is, you already take the minus. Okay, so my answer is we have U1 here, vector unit directions. Vector unit direction is okay, and U2 we have is that right? Okay, now we move on to question number 6. Now let's take question number 6. We are given a function. Let's use the linear approximation to estimate the difference provided that now recall that linear approximations. Okay, recall we have linear approximation that we use to estimate the approximate value of a function fxy would be approached with x0, okay, plus fx 0 y0 multiply with delta x and plus fy. Okay, we have y minus y0. Okay, so for this question, you should observe the difference between the value that we have here, right? So now let's take this one is value of x, and here's y. This one is x0, and this one is y0. So you can see that with this expressions, right? This is from the linear approximation formula. We have that gxy minus g of x0, y0 will approach with gx a plus x0, y0 multiply with x minus x0 and x minus x0 we have here 0 0.15 and plus gy x0, y0 multiply with y minus y0. Okay, this is we have minus 0.1. Is that right? Okay, we have provided gx as 2 minus 5 and gy as x0, y0. So we just need to replace this one. Minus 0.1 multiply with minus 3. Okay. So that the questions give us 0.75. Okay, the next questions. Question number 7. Okay, question number 7. Find maximum and minimum values of the function on the test. Okay, so everyone got the answer for these questions? To ask Nguyễn Hiểu Hậu.
Yeah, teacher.
Let me know your answer. Have you got it?
Give me 3 minutes. I'm calculating.
Okay, so class, do you remember how do we find max min and other functions in a disk? On the disk, first of all, you need to find all critical points inside the disk. Okay. Okay, so have this for this question, everyone. First of all, we need to find the critical point inside the test by showing, right? We need to show the system. We have fx, right? Yes, we have fx here equal to 0, and fy we get 14, right? Plus y equal to 0 also. Then we get the first critical point by and minus. So this point belong to the inside the disk. Is this point inside the disk?
Yes.
Yes, right? Okay, so you have to compute the value of f at b to compare. And next we find critical point on the boundary. Next step, we find the critical point on the boundary. Okay, on the boundary. And the boundary of the disk is the circle. Okay, just equal to 1. All right, so we have some methods to show this, but we can use Lagrange multiplier methods to show this. And in order to use Lagrange method, so we need to show the system, right? Which is next we show the system that we have f okay, sorry, we need to take the derivative. We have fx, okay, minus lambda 2x equal to 0, and also y to y equal to 0. Okay, combining to the conditions. And so from the first two equation, we can get lambda. We eliminate lambda, so we have divided by 2x equal to divided by 2y, right? And so from here we have the relation 13y equal 14x. Replace this into the expression, so we have x squared. Also we have x squared plus y here. Okay, y here. We replace by x squared equal to 1. Is that right? So we get that x squared equal to 13 divided by 27. So we get that x equal to plus minus, right? Okay. So it means that we have two critical points here. We have two critical point square roots when x equal to this value, and we get the second point is minus 13 over 27. That's it. All right, and then now let's replace. Okay, let's replace this point, okay, b2 and b3 into the function. Then you can find out that the value of max equal to approachward, and the value of minimum approachward. Oh, here, sorry. It should take square root, right? So we have here, okay. There was mistake here. I think that's this mistake. Okay, yes. We have, I saw it. Okay. Okay, I already saw the mistake. Okay, so it means that we have here, right? And so x here equal to plus minus 13 by square root of. Is that right? Okay, now let's correct the point, critical point here. And if we multiply this, we have, okay, and also for the second point, and minus 14 divided by. Okay, so now let's check the results at this critical point give us this value of max and min. The next questions. Okay, let's take the next questions. Let D be the laminar Paris inside the circle and about the line, given the density, evaluate the mass of laminar.
Đủ. Cái quái gì vậy bro?
Okay, so what is the mass of the laminar? We have just learned it yesterday, right? Okay, how can we find the mass of the laminar when the region D is bounded by a circle and this is inside the circle and above the line?
Cái gì vậy? Actually fish this. Stop. Em học cái này dưới quê. Cho đúng. Đúng vậy. Đúng vậy. Đúng vậy.
Okay, so how do we find the mass of this laminar? The laminars here takes the shape of circle and above the lines is given the density function. Evaluate the mass of the laminar. Okay, let's recall that the mass here we find by computing the double integral, right? Function rho xy, function density. Here we have dA. And also where the region D here is inside the circle and above the plane. Just mean that we have a circle with radius A, right? With radius A as the line y plus x equal to 0. So we have this, right? We have y plus x equal to 0. We take the above part. So we take the half of the circle of the disk. Sorry, it is the line here is okay, so we have the circle y equal to minus x. Okay, so we have this line, and we take above the line, so it means that we take this part, and this line is y plus x equal to 0. Okay, so it's very obvious. We have to rewrite the boundary. So this one,
It's very
this is the circle
it's
with
immediately obvious.
equation x squared plus y squared equal to a squared. So we have the equation in polar is r equal to a. And the slide gives us that, okay, the slide gives us the equation of tangent of phi equal to minus 1. Now we are going to let the chain of variable x equal to r cosine phi and y equal to r sine phi. So according to the region, you can see that here if we go from the origin to the end, okay, to the end point of the region, so all the arrow here go from 0 to the curve r equal to a. It means that then we have mass, okay, mass equal to the limit integration for r is from 0 to a, and the function becomes 7 r cubed dr, right? And about the phi, you can see that tangent phi minus 1 give us this angle is phi equal to, this angle give us, we have to find the angle with
Minus 3 over 4
and 2.
to 3 over 4b.
Okay, that's over 4 and 3 pi over 4. Okay. So that's the reason is since we have the question, the answer is here. We have this answer. You can see the answer.
So can I have a question?
Why I calculate, I have a different answer according to the what you have tried on the board.
You got the different answer.
Yeah, I do exactly what you are writing on the screen, but yeah.
The answer is not that. Okay, let me check. This is the answer I got. Okay, give me a minute. I'm going to check it again. We have first we have integral, right, from 0 to a of the functions 7x cubed from 0 to a. Okay, and multiply with since we have multiply with by. I got the same answer with the number on the screen.
How Okay. I know. Yeah, because I have the number and multiple to be, so yeah. You right. Both right, but yeah.
Okay. Now let's go to the next question. Okay, we have this questions. Given the function, determine the greatest rate of increase f and n. Compute the rate of change of f in the direction of vector v at this point. So this question number 8, right? Okay, take question number 8.
Kỳ đấy, điểm mai rồi để and the point increase of f and generation. This point is greater rate change. Use that. Chỉ làm nhiều biến. Taylor McLaren. My logarithm figure. So that. So. Lại sao nhờ? Xong rồi nè. That's true, that's my problem is. Why? Trời. Way of change.
Okay, so the questions that we are having here is another questions on directional derivative. And I want to recall that in directional derivative, we have that the fastest increase, okay? The fastest increase is, in other words, we have the greatest rate of increase, okay? Greatest rate of increase of a function. That is the modulus of vector gradient f at the given point. Okay. And next, we need to compute the rate of change of f in the direction of v. They also recall the u f at m as is equal to dot product of gradient f at m with u is 0, where u0
That's true. That's right.
is the unit vector. Remember that we are talking about the unit vector. Okay, the unit vector of in the direction, the unit vector in the direction of u. The unit vector in the direction of u.
Slope nó bên. Nhiều phải rồi. Chính là hữu cơ. Oh, games. Over there. Over there. Over there.
Okay, so do you get the answer, class? So in the first questions, we need to find gradient of f at m, right? More module length of vector gradient. So we need to find fx here. We have, right, Lagrange of yz plus 2xy and replace the point n. Then we get Lagrange of 6, right, and plus. Okay, and fy we have here the derivative of Lagrange equal to, we have x, right, multiply what?
That's true my problem. Shit.
1 over y. Is that right? Okay, and plus here x squared minus z at n. And let's check my calculations. X over y, so we get 2.
Teacher,
Yeah, what's wrong?
ở cái khúc mà x nhân cho 1 phần y phải là x nhân cho 1 phần y z chứ nhờ. U phẩy trên sorry Ska. Ok. Dạ. Em hiểu rồi.
Okay, so let's replace m here and let me know the number. And also we have fz. If you don't get used to do with the general expression, so you can replace, okay? You can fix the point first. Okay, here we have x over z, right? fz minus y. Okay, so then let's replace m here. And so then we have the gradient of f, the length of this vector, square root. Okay, we have fx squared plus, we find square root of square of sum. And then the fastest grade give us, okay, here we have the fastest grade. Okay, so this is the fastest grade.
Furnace increase. Yes, that's true. My problem is this. Cái nhờ f phẩy x bình why you got this 6 nè 2 là 0 plus 6 nhờ so 5 cộng cho x bình trừ z 36. That's That's true, my problem, yo.
And the next questions, okay, in order to find the next question, because we already has gradient vector and vector u0, okay, this is we have vector direction here. So it means that directional derivative of in the direction of v of f at this point is equal to dot product between gradient of f as m and vector v0, where v0, where vector v0 we find by taking the unit vector, right? I don't have equalator here. Okay, so in order to find the unit vector, we have -1, right? This is 1. Okay, divided by, we have here 1 plus a square. In other words, we have here 64 and plus 49, right? Minus a, okay, divide this 1, and minus 7, divide this 1. And so the answer for this, now we have the answer for this, the rate of train.
That's true, my problem
Okay.
was that.
So here's the rate of train.
That's true. Oh, hello.
We can see the results
Yes, that's true.
on the screen.
That's true, my problem was
Okay, so we have minus 20, minus 23. Point 43.
Họ máy tính. Họ máy tính. Mình điểm xíu. Oh shit, that's true. My problem is through this fucking shit, bruh. Bruh, 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 bruh. Ale, 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 to the march in the air. Ale, 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 some of the song, la, 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 la.
Right, now let's take the next. Use Lagrange multiplier to find absolutes. Okay, maximum and minimums of the functions subject to the constraints.
Oh shit, bro. Subjective constraint. Làm nhiều quên tay. Thì bằng ba S cộng Y. 64 nhân 2 á. Ông này nhạc nhẽo phải luôn. Nhạc phải luôn vậy. Subject. Question. Question. Nhạc như nước cấm. Thực tế chút đi mà. This and yeah. Thực tế.
Okay, so sweet.
Yeah, I got like 100% true.
Okay, class, so have you got the maximum and minimum values?
Má, người đâu phải thánh đâu con. Từ. Thánh này. Bằng không. Điệt.
Okay, so for this questions, we do similarly to the previous. We use multiplier, right? Okay, and in order to to use multiplier, we need to show. Now that is to need to show the system fx, right, minus lambda. The condition here, we have the condition, so we take let's take the derivative of g, okay, a partial derivative gx. So we have here, all right, this is equal to 0, and fy, this is we have 1 and minus lambda multiplied with gy, this is equal to 0. We can compile with the conditions equal to 10, right? And from here we have the relation between x and y by eliminating lambda. So we have 3 pi x, right, equal to 1 pi 30y. So it means that we have x equal to okay, we have here 90, right? This is y. And then we replace into this expressions. Okay, we replace x by, so we have here this quite big number y squared and plus 15y squared equal to 10. And so from here we have two value of y, okay, plus minus, and correspondingly we have two value of x plus minus 2. And then you can check, can you check this answer? We have maximum value. Maximum value give us the number of maximum values. Yes, so it says, remember, it is about 1.3. Okay, 1.3 and minus 1.3. It is, can you check that? 1.3 approach and here approach minus 1.3.
I get the 1.43 and minus 1.43.
That's it.
Yeah, it's around 1.3 and 1.4. Because I do the lambda way. I calculate the lambda and then I use lambda to find x and y.
Okay, so now let's check your answer again. Okay, let's check the answer again.
But you know, it's quite different. 0.4. True, that's fucking shit.
Okay, let's see. Is there another questions?
True, that's my problem.
Okay, the next questions.
Then put it on this.
Let's compute the double integral. Okay, so that we compute double integral. What is the region satisfying?
Check the all so check all true things. It's around this. It's around right. Cô ơi, cho em hỏi là lúc ra thi là mình làm tròn mấy số của cô?
Thi trắc nghiệm cho nên là mình sẽ căn cứ vô cái kết quả, ví dụ như là tùy vô cái đáp án của trắc nghiệm mình sẽ chọn cái số đúng nhất thôi.
Ok. Shouldn't very small things. It's my way from this one. That's super thin powder. Satisfying. Yeah, where this is region satisfying. That's true, my problem. Này nhìn không phải thật cực là R bình bé hơn bằng 9 nè, hay là ba lớn bằng không. That's true, my problem was this. Y bằng trừ x là nó đường này nè, mà y là lớn bằng không. So yeah, this would be like this. Lớn bằng không. Mình có là 3 pi phần 4 cho tới pi và d phi, và ở đây là 0 cho tới 3 của r, và yeah, that's true, that's my problem. R nhân cho căn của r bình cộng 3 cộng cho r cos phi.
No, you are not allowed to use material in your exam.
Cái lộn quyền hỏi quyền hỏi quyền hỏi lộn ngon phải shit rồi. Lộn đi vệ sinh.
Okay, so to answer this question, let's get the graph. We have, okay, the regions. Is that right? This is inside inside the circle. We take the part with satisfying y greater than 0 and y less than minus x. Okay, so less than minus, you have to draw the line y equal to minus x here, and y less than minus x means we take the part below the line, right? And so this line we have this one. Is that right, class? So by using polar with this gap integral, we have to use polar here by let x equal to cosine phi and y as sine phi. And so the integral I has just become, okay, the function here give us the functions square root of r squared, right, plus 3 multiply with x replaced by r cosine phi. Okay, here we have r dr. What is the limits for r? Clearly, we have the circle only, so r here go from 0 to 3, right? And about the phi, what is the limits for phi, class?
3b over 4 2b.
Okay, we have 3 pi over 4, 2 pi. Okay, so and you can use your calculator immediately to find this. If we split the integral into the sum of two integral, okay, I can rewrite this like this. Pi d phi, and next we have from 0 to 3, okay, r squared plus 3 dr, that is the first integral, and plus the second term give us, here we have pi, okay, and for the second term we have r squared cosine phi. They in separate form, so we can write cosine phi here multiply with from 0 to 3 r squared dr. Okay, we can rewrite the integral on the left side by the sum of two integral on the right side. Okay, so I think that's the lesson today is enough. Okay, so I wish that you have relaxed the past results to in your midterm exam this Sunday. Goodbye, class.
Cô ơi cho em hỏi bài tập lớn là chia khi nào ạ?
Cô không có chịu trách nhiệm bài tập lớn nha. Bài tập lớn làm với ai đó dạy bài tập của tụi con.
À dạ. Goodbye teacher.
Goodbye.
So, what's your exam? Fuck off. Fucking annoying. Hang on, fucking.
Không có đi. Không có. Hả? Không có thì rồi. Có chưa? Không có. Giờ bây giờ gửi đi. Nghĩ coi để đâu rồi.
Đúng chất bad boy. Bad boys. Biết rồi. No. You high piece, right? sure my problem.
Chắc giờ khoan chút rồi. Giờ cái con chuyển vô tài khoản ba chứ ba có tài khoản không? Ba có tài khoản không? Chuyển ba đi rút lên thẻ ba. Nhưng mà giờ đi rút làm sao? Rút tiền mặt luôn á. Giờ rút nãy ứng ngoại 500 bây giờ rút đưa ngoại.
Về phần những con người chuyển đến, Milan hoàn tất việc tuyển mộ trung vệ Tomori đến từ Chelsea khi mua đứt với giá 29,2 triệu euro. Họ mua thêm Olivier Giroud với con số 1 triệu euro để gia tăng cho hàng công. Những sự bổ sung đáng chú ý khác chính là Mike Maignan, thủ thành của tân vương Ligue 1 Lille với giá 13 triệu euro. Sandro Tonali